This video is about multiplying and dividing algebraic fractions. So let's just have a quick recap of how we can multiply and divide regular fractions. So I've got a calculation here. I've got 2/3 times 3 over 4. Now we could just do 2 times 3 is 6, 3 times 4 is 12, and then simplify 6 over 12. We can simplify that to get 1/2. However, there is a quicker way we could have done that. I could have spotted I had a 3 and a 4, cancelled both of them out, because timesing by 3 and then dividing by 3 will cancel out. And then I can also spot that 2 goes into 2 once and 2 goes into 4 twice. So just by cancelling, we get straight to our 1/2. We didn't need to do any multiplying or any simplifying. We could just cancel, so 2 and the 1, cancel, and we get left with 1 over 2. So this idea of cancelling common factors can save you a lot of time. Dividing. Remember, if I want to divide two fractions, I'm going to multiply by the reciprocal. So I'm going to multiply by the reciprocal of 5 over 6, which is 6 over 5. And then, using the same technique I've just used a moment ago, I can cancel the 5 because that goes into the 10. And now I just get left with 2 times 6 is 12 over 13. So that's a quick recap of multiplying and dividing fractions. Let's have a look at a couple of algebraic ones. So I'm asked to multiply these two algebraic fractions. I'm first going to do lots of factorising because this is going to factorise, this is going to factorise, this is going to factorise. So let's do lots of factorising. That's going to be the key really with this lesson, loads of factorising. The x minus 2, can't do anything with that, leave that as it is. The x squared plus 6x plus 8, two numbers that multiply to make 8, add up to make 6, 4 and 2. Over here, 2x plus 4, well 2 goes into both of those, so I can factorise 2 outside, 2 lots of x, 2 lots of 2. And two numbers that multiply to make 8 and add up to make minus 8 and add up to make 2, 4 and minus 2. Now we've done all of this factorising, I can see that I have got a x plus 2 on the denominator here and an x plus 2 on my numerator over here. So they're going to cancel out. There's no point me multiplying by x plus 2 and then dividing by x plus 2. They'll just cancel. And similarly, I can see I've got an x minus 2 here and an x minus 2 over here. They're going to cancel out. And so actually all I am left with is just a 2 on the numerator and a x plus 4 and an x plus 4, which will give me a 2 over x plus 4 squared. And there we go. Can't simplify that any further, so that is my answer for that one. And second example is a division. We need to show that this fraction divided by this fraction simplifies to be this, where a, b and c are integers. So first thing I'm going to do is to rewrite this division as a multiply by the reciprocal. So leave the first fraction alone. I'm going to multiply the reciprocal of this is this. Next, I'm going to do some factorising. So over here, I've got 1 over. Now, two numbers that multiply to make the minus 6 is a minus 3 and a 2. And I know it's got to have a 2x and a 1, x. And let's just double check this to make sure that I get a plus x in the middle. 2x times 2 would give me a 4x. Minus 3 times x gives me a minus 3x. And we can see that when I do add them together, I just get a single plus 1x. So that works. You could do this the long algebraic method, but I just like to do trial improvement method for factorising these sorts of questions. I know it's got to have a 2x and an x. I know the other two numbers have got to multiply to make 6, so we can figure out it's going to be like that. Over on the right hand side here, I can see 2x goes into 2x squared and 2x goes into the 4x, so I can factorise 2x outside. 2x times x gives me the 2x squared. 2x times times 2 gives me the 4x. And now I can see x plus 2 here cancels out. And so I'm now just left with 1 times 2x is 2x, and 2x minus 3 times 1 gives 2x minus 3. So I've been able to rewrite this in this form, where a is 2, b is 2, and c is minus 3. So key thing with these questions is just lots and lots of factorising.